Electric potential. Potential energy, these are the terms for conservative field or forces. Electric potential is a hypothetical quantity. It is equal to the work done in bringing a point charge from infinity to a particular point. That means when we consider potential, we consider a point as well. But since the definition involves infinity, obviously it's hypothetical quantity. Its formula would be work upon charge unit in SI joule per coulomb, that is volt. 1 volt will be equal to 1 upon 300 stat volt. Stat volt, or you might say electrostatic unit, that is the CGS unit. Potential will be produced positive if charge is positive, negative when the charge is negative. See, the potential of the earth is always negative. The total earth is having additional negative charge. But even then, for mathematical simplicity, we always consider the potential of earth as zero. Simple reason is that whatever amount of charge is transferred from our level to the earth, its potential is not going to be affected much. So, we normally consider the potential of earth equal to 0. And whenever a charged body might be positive, might be negative, if that is connected to the earth, charge will be transferred. It might be from the body to earth or from earth to body, but doesn't matter whether the body is positive or negative, charge transfer is 100% sure. Then important properties of potential, it's a scalar quantity. First of all, potential might be positive, negative, 0, all the values are possible. And since we start defining from infinity, it is said that reference point for potential is always infinity. And moreover, the potential at infinity by a charge shall always be equal to 0. One more thing, suppose there is a point charge and you are interested in finding the potential on itself, that's going to be infinite. Means that's not a point of concern. We normally don't consider the potential by the charge on itself. It's not the point of controversy. See, if there is a point charge Q and you consider a point at a distance R, then at this very point, the potential will be given by the relation. What you notice here is that this is hyperbolic relation. Both are inversely proportional to each other, and there is a hyperbolic relation between the two. The distance will go on increasing from the charge and the potential will gradually decrease. One interesting feature of potential I have pointed out in the figure here, you see, 2-point charges, both are similar. If you consider the point in the middle, both charges are positive, both will produce positive potential that will be added together. But very interesting, it's a mathematical simple trick. Very interesting is that here the potential will be minimum. You see, I'll give you a detailed analysis of this because mathematically you are curious to know why it is minimum. Suppose the total distance is 10. And you consider this point in the middle, then it's going to be Q 1 upon 5 plus 1 upon 5, that is 2 upon 5 means 0.4 Q. And now if you consider point anywhere, say this one, it is 1 and this becomes 9 because total is 10. So it is going to be 1 upon 1 plus 1 upon 9, that will be 9, and 10 upon 9. it is 1.1 Q. And I leave it to you. Now you can try it. You'll find the potential will be always minimum at the midpoint of the line joining them. Now, big question, $1,000,000 question is, can you measure the potential? You are studying potential with such a great enthusiasm, but can we really measure potential at a point? No, not at all. This is the limit of science even today also, because we have introduced the definition of potential in such a manner that it involves infinity. It's a hypothetical, I have reiterated. What we can do is only we can measure the potential difference between two quantities. You see, potentiometer doesn't measure potential. Voltmeter will measure potential difference. So, point to be underlined is that potential is not of much importance for us. It's a potential difference that's relevant, that's significant in our daily life. For example, you want to purchase a bulb. You would say, I need a bulb of 100 watt. Now, the shopkeeper is understanding the potential difference of the bulb is going to be 220 volt. It is understood. You purchase the cell and you say there, I need cell, simple dry cells. It is understood that between the 2 points, 2 terminals, that is cathode and anode of that cell, potential difference would be 1.5. That's ideally known as electromotive force. But that's not point of discussion here. I wanted to underline that potential difference is very important quantity, and that we repeat time and again in our daily life. We always talk in terms of potential difference.